So when we're doing Xbox method, what are the two terms that we need to multiply together first? Yeah, we're going to multiply the 3t squared and the 4. So we begin by multiplying the first term of the polynomial and the final term of the polynomial. When we multiply those two together, we're going to get 12t squared. All right, what number gets put at the bottom of the x? Do we remember? The middle term, right? The positive 8t, that is what gets dropped here, okay? And so now what we're going to try to find out is, well, what combination of factors can we find that are going to multiply to be 12t squared, but add up to be 8t? There we go, right? So it looks like 6t and 2t, right? Both of them positive, right? Because we need them to add up to be a positive 8. So it looks like this is a good combo right here, 6t and 2t. So if we draw out the box, where are 6t and 2t allowed to go in the box? Can they go anywhere, or are there specific locations? Yeah, go ahead and describe. Okay, top right and bottom left. Okay, I like that, right? So kind of like the diagonal, right? The diagonal. So do 6t up here, 2t down here. Okay, here's a hint. Here's a hint, right? What term goes on the top left box? Yeah, we're gonna pull from the actual polynomial, right? We go back to the actual polynomial, and we're gonna use 3t squared. Okay. And what else is gonna go into the bottom right? Yeah, the 4, right? The constant, right? So we end up utilizing those terms a couple of times. All right, and then what's our job at this point? We have to basically do it about 4 times. Yeah, we have to find GCF, right, of every row and every column. So I like starting with the row. 3t squared and 6t. What is the GCF between the two terms on the top row? Yeah, it looks like 3t is my GCF there. Good. What about the GCF between 2t and positive 4? Yeah, that looks like a 2. Okay, so that is my first factor. My first factor is actually going to be 3t, and then since the 2 is positive, it's 3t plus 2. All right, that's my first factor. Now I do GCF for the column, right? At 3t squared and 2t, what is the only thing they have in common there? Yeah, it looks like t is the only factor that they have in common. And then when we get to 6t and positive 4, what GCF do those values have? Yeah, it looks like another 2, right? Positive 2. So since the 2 is positive, that means we're going to have another factor here, which would be t plus 2. And there it is. How do we know which number get the variable? So you would have to look to see, okay, so for example, the first row, I think that's what your question is asking. How do I know that this term needs a t, basically? So you have to look at both of them and like, okay, what do they have in common? So not only can 3 and 6 be divided by 3, but one term has t squared, the other one has t. That means they can both be divided by t, right? They both share the variable t. On an example such as this one, 6t, that's the only term with t, right? So t is not a common term for both of those. So the only thing you can divide by 2. Does that make sense? So they would both need to have the variable in order for you to be able to factor out that variable. Okay, does that answer your question? All right, awesome. Now, why was example 4? Why did I jump right into Xbox method? Okay, the reason why was this. I looked ahead a little bit. I noticed that, hey, 3 has pretty simple factors, 1 times 3. But 4 has a combination that could be 1 times 4, or it could be 2 times 2. So we would have had to guess and test a little bit more if we didn't get it right on the first try. Versus with Xbox method, primarily, you typically don't run into that problem of guessing and testing too many times. Right. So when you end up with more factors, more options for factors than just one option, it means you're going to have to try multiple things. Okay. So your job is to try to get through the factoring as quickly and efficiently as possible. Right. So if you look ahead and you're like, I'm going to have a bunch of different possibilities for factors, let me just jump right into Xbox method because I don't want to have to deal with guessing and testing. Right. That's when it's a good time to use Xbox method. Okay. We could have done traditional method, but we may have run into the problem where it's like, oh, the middle terms are not adding up to 8t. Let's try something else. Let's move them around. Right. And sometimes the fatigue sets in, and then we want to say, like, oh, it's not factorable. Right. When many times it could be. Okay. Any questions on example 4? So our factored form or equivalent form would be right here. No questions? All right, let's move on. Example 5. Okay, so depending on your setup, I believe this probably would be box number 6, or number 5 and number 6. Okay, so make a box here for example 5. Let me know when you're ready. Once again, I'm looking ahead. I noticed that, hey, there's actually multiple factors for 4. There's 2 possibilities. It could be 1 times 4. It could be 2 times 2, right? For 5, notice how the product has to be 5, but the sum has to be -9, right? These are key indicators that tell you my product of my numbers must be positive, but if I add the numbers together, they have to be negative. That means this would have to be -1 times -5, right? We could go through the guess and testing option, but because I noticed that there's going to be multiple possibilities in order for us to be able to get 4x squared, let's instead focus our energy on Xbox method. Let's just get it right the first time instead of guessing and testing every time. Okay, so set up your X. We want the product on the top and the sum on the bottom. What are we multiplying? What 2 terms do we multiply first? That's right. We start with the leading term and the final term. So we end up with 4x squared times +5. This should be positive 20x squared. And what do they need to add up to be? What's going to go at the bottom of the x here? Yeah, they need to add up to be a -9x. So can you think of 2 factors that can multiply to be 20x squared, but add up to be -9x? There you go. You got it, right? So -5x and -4x will multiply to be 20, positive 20x squared, but they're going to add to be -9x. Okay, so far so good. Let's make the box. And we discussed that the terms we're going to use are the ones that we found, right? So the ones on the left and the right, I like to highlight them to remind me that they're going to go into my box. So -5x and -4x. All right. Here's a hint. Here's a hint. What goes back into the top left? Yeah, we want the 4x squared back in the box. And then what goes back into the bottom right? Yeah, the 5, right? So these numbers are used quite often, right? We revisit them multiple times throughout the process. Okay, so now let's take a look. Let's see, what can I factor out as a greatest common factor for every row and every column? Starting with the first row, 4x squared and negative 5x, what do they both have in common? They can only be factored out by 1, that's correct. What else? Yeah, they both have x in common, right? So they at least can be factored out by x. Okay, now what about the second row? Remember that in this case, you're reading that as if negative 4x is the leading term. And then 4 and 5 doesn't look like there's much between them, but what can we at least factor out when the leading term is negative? That's right, we can at least factor out negative 1. So it looks like my first factor is going to be x minus 1. All right, that's my first factor. Now we look at the column. All right, look at the column, 4x squared, negative 4x. My leading term is 4x squared. It's a positive leading term, okay? So I don't need to factor out a negative this time, all right? But they both can be divided by 4, and they both have x in common. So the GCF between both of these will just be 4x. Now take a look at the next term, negative 5x and 5. The leading term is the term on the top. So negative 5x, that means what should we factor out? Yeah, we should factor out negative 5. All right, good. So then that would be my next term, 4x minus 5. So this would be the factored version. All right, we may have gotten that right on the first try if we would have done the traditional method, or we may not have, right? We may have had to do multiple tries. So typically, hopefully what you're starting to see is although Xbox method is more involved, we're able to get our factored form right on the first try, right? And even if you're not sure, like, does this truly give me the original polynomial? You are always welcome to check your work by foiling out the factored form and see if you get the original polynomial. Right? We typically don't do that because it does use up a bit of time, but you can check your work by just, okay, I'm gonna FOIL. Okay, x times 4x, 4x squared. 4x times negative 5, I'm sorry, x times negative 5, negative 5x. Negative 1 times 4, negative 4x. Negative 1 times negative 5, positive 5, right? So all I have to do now is combine the like terms and just double check that the factored format does give us the original polynomial, okay? And in this case, you can see that it does. So Xbox method can seem kind of gimmicky, right? It's like, well, it just seems like a bunch of random steps and it doesn't really make me understand the factoring process. That's because that's kind of what it is, okay? It's a little bit of a gimmick. It's a little bit of a trick, but it does save you time and it usually gets it right on the first try. Factoring the traditional method is like kind of the true factoring, but it's a lot of guessing, testing, multiple attempts. Okay, which is not bad either, but when you're taking a test, you need to get it right. You're trying to, save some time. Xbox method typically will help you get there a little bit faster. Any questions on example number 5? Are there any special cases? There are sometimes. All right, let's take a look at example number 6. Go ahead and copy down the example. There's not a whole lot of special cases, like there are, but they're not necessary to, like, when it comes to factoring trinomials, the way that we do it for any trinomial works on the special cases too. So there's really no need to look only at the special cases of trinomials, because if you understand the methods, you can apply them to those special cases and they still work. And you don't have to, like, even know, like, oh, I'm working with a special case, because sometimes that can be confusing. You just follow your method, usually you arrive at the correct answer. Now with number 6, okay, remember there's always a particular type of factoring you should be looking for at the very beginning, even before you jump into the Xbox method. All right. Now that you're comfortable with Xbox method, or hopefully you feel more comfortable, if you took a look at this polynomial, 6x squared minus 33x plus 15, and your internal Somoza voice was speaking to you, what do you think I would ask you? Yeah, that's the one thing you should always look for every time. Okay, why? Because it makes the factoring simpler. All right, you can shrink the size of your numbers. Not only that, you can limit the possibilities. So let's say you're the person that really likes traditional method. Think about all of the options you might have on a factoring problem like this. You need to try to get combinations for 6. What are those? 1 times 6, or it could be 3 times 2. You need to find combinations for 15. It could be 1 times 15, or it could be 3 times 5. Not only that, they both have to be negative because they have to add up to be negative 33. So look, on both ends of your polynomial, you have 2 different possibilities. Now, let's just say you don't get the possibilities right the first time. You have to test a lot of it. Keep testing in case you're not finding the right values. So one way to simplify that process is to say, well, even before I begin with that, let me first look for a GCF. All right. What is the GCF between or of this polynomial? Is there something that they all have in common? Yeah, they can all be divided by 3, right? And at least that's helpful by shrinking the values of the numbers. So GCF is 3. We divide each term by 3. So now we have 3 times, this is 2x squared minus 11x plus 5. So now let's say you're that person that really, really likes traditional method. You don't want to use Xbox. Look at what you've done for yourself. By factoring out the 3 as the GCF, 2 only has one possibility, 1 times 2. How do I get 5? There's only one possibility, it's 1 times 5. But because it's a positive 5 and the factors add up to be negative 11, they would have to be negative 1 times negative 5. You basically have your factors there, right? They're pretty much done. All right. So I'm going to switch back now and I'm going to do traditional method because this one has only one possibility of factors. We just have to place them in the right location. All right. So we're going to ignore the 3 for now. It's already been factored. We're going to just try to focus on how do I get the right combination here? But those are the only factors I have to worry about now because I was kind of able to look ahead and see that, hey, there's a GCF there. Without the GCF, it's still possible, but then it's a lot more work. Right, so we have the 3 factored out. I know that in order for us to get 2x squared, well, it's going to have to be 1x times 2x, right? That's the only combination that gives us 2x squared. And then in addition to that, the only way I could get positive 5 is to multiply negative 1 times negative 5. Okay, now real quick, the way that I've written it, do you think that's going to work? Or should I have tried a different kind of placement of the negative 1 and the negative 5? Maybe it should be different, right? Yeah, I can kind of preview ahead and see like, hey, that's going to give us negative 2x. That's going to give us negative 5x. That doesn't add up to be negative 11x, right? Because what I'm trying to get to is here. I'm trying to get to this because this is what I'm factoring now, the 2x squared minus 11x plus 5. So I'm probably going to need to switch around the placement. I probably should have done negative 5 here, negative 1 here. All right, let's see if this works. Negative 5 times 2x, negative 10x. 1x times negative 1, negative 1x. So the sum of these 2 terms would be negative 11x. Okay, so that checks out, okay, because that's what I was factoring. Okay, I'm not trying to get back to 33. There's no way I'm going to get back to 33 because I already divided a 3 out of it. So this would be my factorization. What do I need to bring down in order to have a complete answer? There we go, right? I have to bring down the 3. It's part of the original process. It's part of the original polynomial. So this would be our factored version. So you see, I'm bouncing around between like Xbox method, traditional method. There's no right or wrong one. It's just preference, right? And sometimes you'll see like, oh, this one's kind of easy, just directly like straightforward, right? And the other one would, look a little different. Would 2x minus 3 times 3x minus 5 be incorrect? That would be incorrect, yeah. Because your middle terms would not add up to be negative 33. Your middle term would have added up to be negative 19x, not negative 33x. So that would be incorrect. How could we have we forgotten about the 3? It's possible. Sometimes you'll just box the last, right? But we need the 3. But technically terms of same. Yeah, go ahead. What's your question? The arrangement. Oh, so you mean, let's say I would have had 3 times 2x minus 1 times x minus 5. Would that be the same? Are you asking? Would that be this? Would that be correct? Okay. So the full factor can be moved around, but like switching just like 2x and 1x sometimes, that doesn't always make it correct. But like having 2x minus 1 in the front and x minus 5 in the back is the same as x minus 5 times 2x minus 1, right? Like moving the full factor, the full parentheses around, swapping them this way, that's fine. But I can't just take like 1x, 2x and flip it and then get the same answer. That's the tricky part. You have to respect the rings. Yeah, you have to respect the parentheses, basically. If you're gonna move it around, you gotta drag the whole parenthesis group. Okay, because if you then try to check your work and you FOIL everything out, you might get a different polynomial. All right. So I guess, how can I explain it? You have two Skittles bags, but they're sealed. You can just move them around, right? They're like the same thing. But if you open the bag and you take out some Skittles from this one, open the bag on this one, you swap them around, I guess that's different, right? Like that. That's kind of what I'm trying to say. If you didn't understand my Skittles reference, don't worry about it. All right, let's move on. Go ahead and try these two out on your own. Okay, try out 7 and 8. All right, give you a chance to work on these without my guidance for now. Try them out and then we'll check back in. What approach you think might be best for this particular example? A little Xbox, a little traditional, probably box. And the reason for that is because 6 has multiple options. And we're not sure which one, right? So we might have to do a lot of guessing and testing. So instead, let's eliminate that possibility and we just jump straight to our X. We're gonna take the factors, we're gonna multiply, 6x squared and 5. So this multiplies to be 30x squared. We want it to add up to be 13x, right? We want this to add up to be the middle term of 13x. So I'm looking for 2 factors that will do that for us. And I think, Haley, this is one you were talking about. There you go, right? So it's 10x and 3x, right? Multiplies to be 30x squared, but adds up to be 13, okay? So in our box, on the diagonals, we're going to use the 10x, and we're also going to use the 3x. We reuse, right? We reuse that leading term, 6x squared, in the top left, and we reuse the constant of 5. So GCF time, go across that first row. What is it that they both have in common? That could be divided by, yeah, 6 and 10 can both be divided by 2. Not only that, they both share x, so 2x. What about that bottom row? Anything they have in common? Yeah, just one, right? Just one. Okay, so first factor, 2x plus 1. Let's go on the column now. Looking at that first column, 6x squared and 3x, what is the GCF? Yeah, we have 3x, right? 3 divides 6 and 3. X can divide x squared and x. And then finally, that last column, 10x and 5. Yeah, it looks like just 5. So my next term would be 3x. That 5 is positive, so it's 3x plus 5. Okay. If you really want to, double check your work. Make sure that it gives you the equivalent expression. It gives you the original polynomial back. Okay. Any questions on number 8? All right. Last one. I'm going to jump straight to example number 10. Okay. Number 10 doesn't happen often, but there are times when maybe polynomials cannot be factored, right? We know this because there have been other cases before, maybe other types of polynomials, maybe only the binomials, but sometimes there are trinomials that cannot be factored, okay? Now, Xbox method is a little bit more helpful to determine whether it can or cannot be factored. When you have to do a guess and test, you have to basically go through all the options before you decide, hey, this isn't factorable. So like I said, even though I'm typically more inclined to like traditional method, I have kind of grown fond of Xbox method because there are problems where you might spend 10 minutes on it trying to figure out if this is factorable because you're trying to use the traditional method. All right. So if you look at an example like this, you might not have any idea whether this is factorable or not, right? But you can see how there are lots of options for 4. Not lots, but there's at least 2. 27, there's a lot because it has to multiply to be negative 27. So imagine you could have negative 3 times 9, but you could also have negative 9 times 3. 2 different options. You could have negative 1 times 27, or you could also have negative 27 times 1, right? Just for negative 27, there's 4 possibilities of factors. So this is probably one where you're like, this, I don't want to approach this in a traditional way. Let me try Xbox, all right? So we're going to look to find the product and the sum of these two numbers. 4x squared and negative 27. Somebody help me out here. When we multiply 4x squared times negative 27, what do we get? Yeah, we get negative 108 x squared. And what does it need to add up to be? What would the factors have to add up? Yeah, it would have to add up to be negative 13x. So take your time. Try to find a combination of numbers that could work. That would multiply to be negative 108, but also add up to be negative 13. So if your goal is just first, let me just kind of narrow, let me just look at the factors of 108. There's a lot, but remember they would have to multiply to be negative 13. So the numbers have to be kind of close together. They can't be too far apart. So, one option would be, okay, like maybe negative 54 times 2. That wouldn't work no matter how you move that negative sign around because the numbers are so far apart. They're not going to add up to be negative 13. So that's kind of obviously wrong. What else might work? Or numbers that are within the realm of possibility. Yeah, maybe negative 27 times 4. Again, too far apart, right? Negative 27 and 4, the gap is like 23, not 13. That's not going to work. $18 and 6, does that work? 60 and 48, yeah. Okay, negative 18 times 6. But what's the gap between, when you add those together, that's negative 12, right? Not negative 13, so doesn't work. The other one could have been like negative 12 times 9, but that, again, that is negative 3. That doesn't work. So at least the possibilities, we've kind of run through them when we narrowed them down, and it's like there's not really anything here that's going to add up to be negative 13. So do you see how in this situation you run through the options, but you looked at just, this is the goal, multiply to negative 108 and add to negative 13. And if it doesn't satisfy that, then you are a little bit more comfortable in saying, hey, this is prime. And in this case, it is. There are no factors, right, that satisfy that. So then what it's indicating to us is like, we can't move forward. We can't even get to the box. Therefore, this is a prime, right? It's not factorable. So we're going to call this a prime polynomial. There's also no GCF, right? 4, 13, and 27, there's no factor that can divide all three. So we're comfortable with saying, hey, this is a prime. Right? We went through the realistic options and none of them worked. None of them added up to be negative 13. So we have a prime. Okay, now this is possible, right? Sometimes it happens, but always kind of run multiple steps, try multiple times. Don't arrive at prime as your first conclusion. A lot of times, that's where the common mistake is I tried it one time and it didn't work, prime. You know what I mean? Like, we love saying stuff like that because we don't want to try more. It's just, oh, it didn't work the first time for me, so it's a prime, okay? You got to run through the process a little bit more.